Hello everyone, welcome back to this channel. Today we are going to study an interesting topic that is feature engineering. The term sounds difficult, but the concept is not. Anyway, it has three categories: feature selection, feature transformation, and feature extraction. First of all, let me tell you the concept. Feature engineering is transforming raw data into relevant features so that they can be used as input for machine learning algorithms. Simple, you have to make the raw data into something informative. And this can be done in these three ways: selection, transformation, extraction. Okay, first let me tell you a simple story, then these things will be clear to you. Suppose you want to create a pizza. You are a lover of pizza. Now, in your kitchen, you have multiple items, but you want only those items which are required to make this pizza. So, you will take onion, tomato, garlic, capsicum, mushroom, flour, yeast. Okay, but you are not taking all the ingredients. So, you are selecting some ingredients. Okay, so in your data set, you have many features, but you are selecting only those features which will be able to fulfill your purpose. You get my point? You are selecting some features. So that is why it is known as feature selection. Fine. Now next, you have to make them ready. So you have to cut the onion, you have to chop the tomatoes, the capsicum, the garlics. Okay, so you have to transform the features. So in your data set, you may need some scaling, some log normalization, some min max scaling. You have to transform the feature so that they become ready. Okay, after you have selected, now you have transformed. This is known as feature transformation. Clear? Now you have to make the sauce. So you use tomato, garlic, olive oil, black pepper, whatever you want to give. You create a sauce for the pizza. So here you are simply transforming the available ingredients into something useful. You already had all those ingredients. Now you have created the sauce. So simple things. You are extracting something from the available ingredients which is to be required for creating the pizza. So same here in the data set, you are creating some features. Suppose you have a column called date of birth. Now you can calculate the age from the date of birth. The age may be directly used by the machine learning algorithms. So you are creating some features from the available existing features. You get my point? You are extracting some information to create something new from those which are already available. This is known as feature extraction. Simple. First, you are selecting the ingredients called feature selection. Next, you are transforming them. This is called feature transformation. Next, you are something extracting from the available features. That is feature extraction. Now you can create the pizza. Now you can model your data set. I hope you like this simple small story and you understand all these things, because I saw people get confused. I don't know why, but I hope now it's completely clear to you. Like what is feature engineering? All these three together known as feature engineering. Okay, so meet in our next video. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. In our last class, we understood what is feature engineering. It consists of three parts: feature selection, feature transformation, and feature extraction. What is feature selection? Selecting only those features which are required for your modeling. Feature transformation, changing the original features into something new so that it becomes more suitable for model building. And feature extraction was extracting the features from the available existing features. Okay, you remember all these things. Now in this session we are going to learn the different techniques of feature transformation. How you can change the original features into something new. Okay, first one is scaling. Why scaling is required? Suppose in your data set, some values are extremely large, some values are extremely small. So what happens? Larger values have more impact in comparison with the smaller values, but maybe all of them are equal. So there is a bias in your model. So in that scenario, simply you have to bring them into a range. You have to scale your data. Okay. Now it can be done in two ways: normalization and standardization. Now, in normalization, data points of that particular column will lie between 0 and 1. So if you apply this formula xi, the data point, x mean the minimum value, x max maximum value of that column. If you apply this rule on every data point, then every data point will be in between 0 and 1. The minimum value will be 0, the maximum value will be 1. Clear? Now let me show it to you. Then it will be more clear. This is a single column data set. Just see, only one column, and on that column I will apply normalization. Okay, so that every point gets scaled. Okay, now see here, min max scalar is a class which is already in sklearn library. Now I have to create an object of this min max scalar. Scalar equal to min max scalar. Okay, now let me run this. Fine. Now I want a new column. I'll name it scaled underscore edge equal to scalar object. Fit transform function will be applied on edge column. See now. So if I just show it to you, see the output. See, the minimum is 0.0. Minimum value was 21, maximum value was 40. So 40 has become 1 and all others are lying between 0 to 1. So your data is scaled. Now there are less differences. So all of them will have now almost equal priority. Okay, this is what is known as normalization. Now the next one is standardization. This is also same. You scale the data, but here your target is that mean will become 0, standard deviation will become 1. I'll show it to you on this data set. For that scenario, I have to import from sklearn.preprocessing import standard scalar. Standard scalar is the class where the function is written. So now I will create one more object of this class. Okay, scalar 1. Now I will create a new column. Name it standardized underscore edge equal to scalar 1 dot fit transform df edge column applied on edge column. Okay, now if I try to show it to you, so two new columns have been created. Let me show it to you. Df, see, in this column we have applied min max scaling. That's why the value is between 0 to 1. Maximum is 1, minimum is 0. In this column we have applied standardization so that the mean of this column becomes 0 and the standard deviation becomes 1. Let me show it to you also. Suppose if I write df is dot mean. So on this I want to see what is the value of mean. See, the mean value is 30. But what is the mean value on this one? df standardized is dot mean. Now if I run it, see, it is not 0. Theoretically it is 0, but it is always near to 0. Okay, not exactly 0, but near to 0. Now let's check the standard deviation value. So df is dot standard deviation 7.59. Now it will become 1 for the standardized edge dot std. Now see, this is also near to 1. Okay, so you understand the difference. For min max scalar, the minimum value will be 0, the maximum value will be 1. This one. For standard scalar, the mean value will be 0 and the standard deviation will become 1. Okay, simple. So these are the two ways by which you can do scaling. Now the next one is log transformation. We have already learned that by using log transformation, we can mitigate the effect of outliers. You remember we did one class on that, how to mitigate the effect of outliers instead removing the outliers. Okay, same concept here also. If your data set is skewed, then you can apply log transformation, then it will become almost normal. Okay, not exactly normal every time, but will become almost normal. But how? Do you remember how and why? Because skewed dataset means your dataset is having a wide range, but when you apply log on something, it mitigates the values, so it becomes the range smaller. So that's why it doesn't look skewed anymore. It becomes almost normal. Anyway, let me paste it here and show it to you. First, I have imported the necessary things. Now I have taken a right skew distribution. See, 100, 1000, 10,000, 1 is 1. So simply this is a skew distribution. Now plot dot figure, just give the figure size. And here I have done KDE plot using C1 library. And this one is just decorated. And now there is the formula. So np dot log data. Okay, that means on this data set, um, on this data, you have applied the log. Okay. Next, again, I have created a KDE plot. Just let me show it to you. See, this one is the skewed distribution. Can you see? Right skew distribution, right tail is longer. But after you have applied the logarithms, again you have plotted KDE plot. Here you can see that it is almost normal. Normal distribution, you know, mean and median values are almost equal. It looks like a bell-shaped curve. Distribution is equal. Okay. So this one is skewed distribution. This one is normal distribution, almost normal distribution after you have applied logarithms. Okay, so we have understood standardization, normalization, and log transformation. Okay, so in our next class, we'll understand Box-Cox transformation. Okay, so meet in our next class. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. So let's continue feature engineering. As of now, we have completed scaling, normalization, standardization, and log transformation. Now let's understand Box-Cox transformation. If your dataset is skewed, then you have to make it normal distribution before you apply the model. So in that scenario, Box-Cox will help you. The same thing is done by log transformation also. But it is considered to be more flexible because log cannot handle negative values, cannot handle zero. So in those scenario, Box-Cox helps you. Now there is a concept called lambda parameter. This is simply a parameter which maximizes the normality. So first you have to calculate the lambda value, then only you can decide which transformation will be applied. Okay, so depending on the lambda value, you have to decide which transformation must be applied on the dataset so that the normality can be maximized. Clear? Now let's do it with the dataset, then it will be more clear. Let me copy the data. Just paste it here. Here I have imported NumPy, Matplotlib, and see here Boxcox NormMax from SciPy library. Okay, a random data set is generated dot exponential size 1000 so that the dataset becomes skewed. Now let me show you the dataset. See 1000 data points. Okay, now if I just draw the KDE plot, then you will be able to see that the data is a skewed data. Now see here, see the data is right skewed. Okay, so we have to make it normal. Now for that, first I will calculate the lambda opt. So lambda optimized equals to Boxcox Normax data. Okay, it will calculate the value of lambda, the value of optimum lambda. Now after it has calculated the lambda, then it will apply the techniques. Depending on the lambda, any kind of techniques will be applied. You don't have to do anything. Everything will be done by the functions only. Okay, so we have to write uh, Boxcox applied equals to Boxcox on data. The parameter is lambda op, whatever we have calculated right now. You can directly write Boxcox Normmax data here also. Okay. Now see this data set. If you compare the data set, you will be able to find the difference. Anyway, we will do the KDE plot. Then it will be more clear. So if we write KDE plot on Boxcox A, if I run it, now see. data is much better. It is not right skewed anymore. You remember the data set SNS dot KDE plot on data. See, previously it was like that. Now it is much better. Almost normal. Okay, so simple. All you have to do is to just calculate the lambda parameter. You don't have to calculate, but it will be done by Box-Cox Normmax. Then you have to apply the Box-Cox transformation. Okay, so your dataset will become almost normal from skewed dataset. Okay, this is a simple topic. Okay, now if you want, you can see by histogram also. Just write plt dot hist. First apply it on data. See the histogram, skewed histogram. Now apply this on Boxcox A. Now if I run it, much better. Okay, fine. So this is a simple topic, and in our next class we will understand how to encode any categorical variables. Okay, so meet in our next video. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. So today we are going to understand how to encode categorical variables. Some machine learning algorithms do not understand categorical data. They can work only with numerical data. So in that scenario, you have to convert your categorical data into numerical data. This conversion can be done in many ways, like label encoding, one-hot encoding, ordinal encoding, and binary encoding. We will understand about all of this in details. Okay, now the first one is label encoding. Label encoding assigns a unique integer to each category. Like here you can see that the color red, blue, red, green. Every category will be converted to an integer. Red may be 0, blue may be 1, like that way. Okay. Now first let me copy this. Then you will be able to understand. Just run it and df. Simple one column that is color. Okay. Here I have imported label encoder. This is a class already written in sklearn library. So I have to just create an object of this class. So I write L equals to label encoder. Let's run it. Okay, now now I will create a column df column name uh, encoded underscore color equals to L dot fit transform on color column. Now if I run it, see if I show you the df, you can see encoded color, new column created, and red is 2, blue is 0, green is 1, blue is 0, red is 2, green is 1. So in this column can be understood by the machine learning algorithm. For some algorithms you have to do, not for every algorithm. Okay, so this is a simple conversion from a category to a numerical. This is known as level encoder, and it can be done by level encoder class, which is already in sklearn library. Fine. Now next understand one-hot encoding. One-hot encoding creates binary columns for each category. Like see here, color the same data set. I'll just copy it and paste it here. Now if I do one-hot encoding, then output will be like red, blue, green. All three categories will become columns. Now red means this one will be 1, but this will become 0, 0. Binary numbers. Blue will become 1. This will become 0, 0. Next one is green. So green will become 1. Next will become, this will become 0, 0. Blue is 1. So 0, 0. Next is red. So red will become 1, 0, 0. Green. So green will become 1, 0, 0. Okay. So you can understand. This has been encoded, binary encoded. This is known as one hot encoder. Now let's do it. Okay. So I will do on the same data set. So just copy this one, paste it here, import one hot encoder. Okay. Now just check the data set once again. DF, it has color. On this column, we will apply this one hot encoder. Okay. Now let's write. Um, First, we have to create an object. So O equals to one hot encoder. Fine. Now I will write one hot encoded equals to O dot fit underscore transform on df, not on encoded color. We will do it on color. Okay. Now see what is the output. So I can copy. See the output. This is a sparse matrix. So I have to make it sparse equals to false. Sparse matrix means it has many zeros or missing values. So in that scenario, we have to write sparse equals to false. Now you can see 001 100 010. Now make it a data frame. Then it will look better. So I can write one hot encoded underscore df equals to pd dot data frame one hot encoded, and column names will be columns equal to o dot get feature names. Column names are feature names, so you have to get the feature names and make them the column names, because here you can see that three columns are generated, so you have to make them column name. Now if I print this one, you will be able to understand. Sorry. See, blue, green, red. Let me show you the data set. If I write df, red means 001, red is 1, blue, so you can see blue 1, green, so you can see green 1, others are 0, blue, so blue is 1, others are 0, red, so red is 1, others are 0, green, so green is 1, others are 0. Okay, so you get my point that all the categorical columns are converted into numerical columns and binary columns. Okay, this is what is done by one hot encoding. Okay, so now next understand what is ordinal encoding. Ordinal encoding means when you have an order. In that scenario, you will use ordinal encoding. Let me first copy the data set. See, this is the data set. If I write df, two columns, customer ID and their satisfaction level. See, satisfied, very satisfied, neutral, very satisfied, unsatisfied. So you can find that there is an order like low, medium, high, good, bad, average. They have an order, or education level like bachelor's degree, master's degree. In these types of categorical variable, you can apply ordinal encoding. Fine. Okay, so first I have to create categories. So let me first copy this one and run it. Now I will create an object O equals to ordinal encoder categories equal to categories. Fine. Now let's create a new column. df uh, satisfaction level encoded equals to OE dot fit transform and df on which column? Satisfaction column. So on that, this one will be applied. Now if I print this, just let me show it to you. See here. See, this is the satisfaction level. 3.0, 0.0, 2.0. Let me show you the data set, then it will be more clear. Customer ID, satisfaction level, encoded. 0.0, very unsatisfied. 1.0, unsatisfied. Neutral. satisfied 3, very satisfied 4. So you can see that there is an order. Whenever you get something like order, then you can convert it into this way. This is known as ordinal encoding. Fine. And the last one is binary encoding. Here it combines both level encoding and one hot encoding. What is done in level encoding? In level encoding, you assign an unique integer. In binary encoding, you create binary columns. Here both are done together. Let me first show it to you, then I will explain. Just copy and paste. Sorry, I have to install pip install category encoders. After it is done, then I can. It is not done yet. Here I am importing category encoders, named it as CE, and only one column New York, Los Angeles, Chicago, Houston. This is converted into a data frame. CDF. Okay. Now initialize the binary encoder. So I have to write binary encoder equals to CE dot binary encoder. Now encoded underscore DF equals to binary encoder dot fit transform on DF. Okay, let's run it. Just see what is the output. See, this is the output. So CT0, CT1, CT2. Okay, now let me tell you how it is happening. This is a combination of both label encoding and one hot encoding. So in label encoding, first it will be converted into a number. So here, in this data set, just let me show you the data set first. New York, Los Angeles, Chicago, Houston. Okay, suppose to New York, I will give to New York, this is 0. For Los Angeles, 1. For Houston, it will be 2. For Chicago, it will be 3. And Chicago equals to 3. Just a unique integer. Okay. Now they will be converted to binary numbers. If 0 is converted to binary numbers, the value will be 0, 0. If 1 is converted, the value will be 0, 1. I hope you know how to convert this by dividing it by 2. Like 1 is divided by 2. If 2 is converted to binary, the output will be 1, 0. Do you know how to convert it to binary numbers? I hope you know. Everybody knows. No problem. If you don't know, just learn it. You have to divide it by 2. Now the remainder is 0. Now you have to consider it in this way. So it will become 1, 0. Okay. What is the output for 3? If you convert it into binary number, it will be 1, 1. Because if you divide 3 by 2, then both of them will become 1. Okay. Remainder will also be 1 and this one will also be 1. So if you write it 1, 1. Okay. Simple. First they are given in unique category. Then they are converted into binary numbers. Okay. That's what it is happening here. So 0, 0, 1, 0, 1, 0, 0, 1, 0 like this one. 0, 1, 1, 0, 1, 1 this one and 1, 0, 0. 1, 0, 0 means 1, 0. Okay. So these are the 4 types of encoding you can do. First one is level encoding, where you assign a unique integer. Second one is one hot encoding. There you create binary columns for each category. When there is an order, you use ordinal encoding. And when you want to use both of the level encoding and one hot encoding, you may do this binary encoding. Okay. Now tell me why to use this one, binary encoding. Because this is more efficient than one hot encoding when you are dealing with large number of columns. If there are many categories, like red, blue, green, yellow, purple, many categories. For each of them, one column will be generated. So there will be so many columns. It will be like sparse matrix, and it is always difficult to handle a sparse matrix. In those scenario, when you have large number of categories, you can use binary encoding. Okay. Because here it is first encoded into a number, then it is binary encoded. So that's why so many columns will not be generated. So binary encoding is much efficient than one hot encoding. Okay. So these are the ways you can transform your features from categorical to numerical variables. This is an important point of feature transformation. Okay. So meet in our next video. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. Let's continue feature transformation. As of now, we have completed scaling, log transformation, box cost transformation, how to encode categorical variables. Now we are going to understand what is binning. Okay. Binning means converting continuous features into categorical ones by dividing them into intervals. Suppose you have a continuous features and you want to create a category of them. Okay, see here the example. Here I have a column named age. So we have a age of many persons, right? Now you want to create a category of this age column. So how can you do this? So you think that if the person's age is 0 to 18, the person is child. If the age is between 18 to 35, he is youth. If the person's age is 35 to 50, that person is an adult. 50 to 65, then middle age. 65 to 100, that is senior. So simply you have created some intervals and then you have made them a category. Okay. Now you take the age 22. So the 22 will come under 18 to 35. So the person is youth. 25 youth. 47 adult. 35 youth. 46 adult. 50 middle aged. 65 senior. 68 senior. 70 senior. 45 again adult. Okay. So you have age, you have the continuous column, you have the continuous features. Now you want to convert them into category. So you have converted them into category by creating an interval. Fine. Now let me show you the code. See here, this is the code. You have column named age and you have all the ages of persons. You have converted them into data frame. You have created bins and you have also created labels for them. Okay. Now you convert these numerical columns into this category. Now let's do it in Colab. First, just check the data frame once. And we have defined the bins. We have defined the levels. Okay. Now we have to write df. Within this, we can write age group pd dot cut. Cut function will create the intervals. And here we are providing the age column, bins equal to bins, levels equal to levels. Because we have mentioned here as bins and levels. So this will become the bins and this will become the levels. Child, youth, adult, middle-aged, senior. Okay, now let's run this. But before that, okay, we have imported pandas. Then fine. So just run this. Okay, now let's see what is DF. See, so you have created 5 categories. So if you have many ages, all of them will be converted into 5 kind of categories. Sometimes you may need this kind of columns for your machine learning algorithms. So in those scenarios, you can simply convert these continuous features into categorical. Okay. Now if you want to visualize this, SNS dot count plot x equal to age group and data equals to the data frame. I'm very sorry. Import C1 as SNS. Now, see child, because there is no person in child category, youth, adult age group, middle aged, senior. So you can easily understand that maximum are adult. Okay, no child. Visualization is always easy to interpret. Now, if you want, we can create his plot also. So import matplotlib dot pyplot as plt. You can create by C1 also. Anyway, plt dot hist plot, sorry, hist df df on age underscore group, right? Now let's run it. See, as there is no one in child group, that's why it is not shown here. Okay, so you can use his plot, you can use count plot, and you can analyze your data. Anyway, the main part is converting the features into categorical ones. Okay. Now our topic is reciprocal transformation. Transforming features to reduce skewness and to manage large differences in scale. And this transformation is particularly useful when the data has a skewed distribution with a long tail towards small values. Now, suppose if you have two numbers, one is 50 and the other one is maybe the other numbers are lying between uh, 15 to 35, like that. In comparison with them, these are extreme. Small values, large values. Now, suppose if you make the reciprocal, then what will happen? 1 by 50, right? Reciprocal of this one, 1 divided by 2. 1 divided by that number is the reciprocal number. So now the output will be 0.02. Here the output will be zero point 0.5. So now this one has become larger from this one. Okay. And they are comparatively closer to each other than before. Okay. So here what we do? We make the reciprocal of each data points so that the larger value becomes smaller, the smaller value becomes larger. That is also done to reduce the skewness. This is simple. Just we have taken a value. Just let me show it to you. If I just paste here and see, let me run this. See here what happens. 1 divided by 1, 1. 1 divided by 2, 0.5. 1 divided by 5, 0.2. 1 divided by 10, 0.10. 1 divided by 20, 0.05. Okay. So this is also a type of feature transformation. Now let's understand what is polynomial features. Polynomial features means creating new features by raising existing features to a power or by multiplying them together. Let me show this to you, then this will be clear. Just copy. Now see, there are two features, 1, 2, 4, 5. Fine. Now, polynomial features is the function. You have to mention degree. First, let me give it and it will be easy for you to understand. Okay, now we have just applied fit transform. We have applied this many times before by calling this object. First, we have created an object, a polynomial features class, and then we have applied fit transform. So what happens here? First, we are taking the squares of first feature, then we are multiplying the features, then we are again taking the squares of the second features. Okay. Now, if you want, you can simply increase the degree by writing degree equals to 3. Okay, same. First square, then multiplication 1 into 4, 2 into 5. Then again square, 4 square 16, 5 square 25. Here I have written the rules. Feature 1, feature 2. Feature 1 square, feature 1 into feature 2. Feature 2 square. Next feature 1 to the power cube. So 1 cube, 1 2 to the power cube, 8. Fine. Next, feature 1 square into feature 2. Feature 1 square means this one, 1 and 4 into 2. So 1, 4 into 2, 8. Fine. Now again see, feature 1 into feature 2 to the power square. So what is feature 2 to the power square? 16 and 25. So you have to multiply 1 into 16, 2 into 25. So you can see 16, 50. Okay. And again, last one, feature 2 to the power q. So we can do 4 to the power q. 4 to the power q means 64. 5 to the power q means 125. Okay, so this is also a way by which you can transform your features. This is known as polynomial features. Okay, you can just follow this formula and then you can understand. You just have to call the polynomial features class. Okay, and it is used when dependent and independent variables are non-linear. Okay, when you will understand SVM algorithm, support vector machines algorithm, there it benefits a lot. Okay, now let's understand interaction features. Interaction features means you just have to write interaction only equals to true. Nothing. Let's first make it true and interaction only equal to true. Then see what happens. Just a small change. Hmm, yeah, I have forgotten a comma. Just a small change. Just the multiplication of. Okay. So you don't do the power change. You just multiply 1 into 4, 2 into 5. So depending on your need, you can call the interaction only parameter or you can do the complete transformation. Here it is done both power and multiplying together. But here only multiplication. Okay. So we have understood many techniques of feature transformation and all this will depend on your need. As per your need, you have to transform the features. All these things are done before you model your algorithm. Okay, and in our next class, we will understand how to do feature extraction. So, meet in our next video. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. So, we know that feature engineering has three parts: feature selection, feature transformation, and feature extraction. We have understood what is feature selection and we have learned many techniques of feature transformation. Now let's understand what is feature extraction. Feature extraction means creating a new features from the available existing features. Suppose in your dataset you have date of birth column, but you want to know what is the age. So you are creating a new column, that is the age column, from the date of birth column which is already available, already existing. So this process of creating new features from the existing features known as feature extraction. Simple. Now in this class we are going to do many examples so that you understand how to do feature extraction and how and when to apply these techniques. Okay. Now first I have copied this data. Okay. So now let's paste it here. Just check the data set. It has some columns: transaction amount, transaction date, customer age, customer location, and payment method. Anyway, I want to extract the month from this column. Okay, for some reason, I may need that only the month, not the whole date. So I have to create a new column from this available date column. First, I have to check what is the data type because most of the time it is object data type. Here also it is object. So you have to convert it to date time data type. Then only I can apply some date time function. Okay. Now for that I have to just write pd dot to underscore date time df transaction date. Then it will be converted into date time column. But this is not permanent. So just copy it, keep it here equals to. Now I'll just check it once again. Df dot d types. See, now this is date time column. Fine. Now what I want to create a new column having month. So just write df, name the new column month equals to df transaction date dot dt dot month. Now let's run it. So you can see that there is a new column called month. See 1 February month, March 4, April. Okay. Now, if I ask you a question that I want to convert this into quarters, first quarter, second quarter, third quarter, fourth quarter. So, what techniques will you use to do this? Can you write in comment section? Anyway, I'll tell you the example, that is binning. If you have not seen, then see the last class. There I have explained how to do binning, how to convert numerical continuous features into categorical ones. Okay. Anyway, that's not today's topic. So this is the way we can do. In fact, if you want DF, you can do for day. If you want, you can do the same for year. Okay. So maybe due to some operations, you may need these things. The day is separated. If you want, you can separate the year also. Okay. So you can simply just create new features. Okay. Now let's do the second example. Textual features. This one I can't explain you right now because this is a technique of NLP. There you can convert the text data into numerical columns. This is done using this term frequency inverse document frequency. But this one you will not understand right now. You must have some idea about NLP, natural language processing. Then only we can understand. There this technique is used very much. Okay. Anyway, now third example is using mean, median, standard deviation. Though we know these things, still let me show it to you once. So just let me paste this. And now if I run, see here two columns, customer ID, transaction amount. Now I want to create the mean of the transaction amount. Mean value for every customer ID. 1, 2, 3. So I will create group by of this customer ID. So first I will take all the one customer ID and then I will calculate the mean of the transaction amount of customer ID 1. Mean of the transaction amount of the customer ID 2. Mean of the transaction amount of the customer ID 3. Just let me show you the output. So you will create two new columns. One is mean transaction amount and yesterday transaction amount. Okay. See, this is done. For the customer ID 1, the transaction amount is 100, 150, 200. So if you just add them and calculate the mean, it will be 150. Okay. And same way, standard deviation is also calculated. For 2, 50, 75. So if you average them, it will be 62.5. Same way, the standard deviation. For 3, 300, 400, 450, 475 divided by 4. This is mean and this is the standard deviation. Okay, so this way also you can create new columns. Depends on your need. Okay, now the next one is categorical features. Categorical features we have already learned. These are the techniques of feature transformation for changing the categorical columns to numerical columns. This is mainly feature transformation, but as you are creating new columns, new features, that's why it can be called as feature extraction also. Anyway, all of these are part of feature engineering. So, feature extraction is about transforming raw data into something more informative, more useful. Okay, and the choice of techniques depends on the nature of your data and the specific problems you are trying to solve. Okay, so congratulations, we have understood what is feature engineering and practice a lot. And we will meet in our next video. Till then, bye. Happy learning.